I'm Adam Pritchard, Assistant Curator of Paleontology at the Virginia Museum of Natural History, coming to you from Martinsville, Virginia, with more tales of ancient life. Now today, rather than talk about a specific Virginia Museum of Natural History specimen and how it's important for the VMNH, I'm going to be talking a little bit more about the general paleontologist toolkit, basically what we do in order to discover those ancient lives. And there's actually one part of the toolkit that's sitting on my table right here, right now. Eagle-eyed viewers may have noticed something that looks somewhat out of place, but it'll make sense in a little bit. Roll of toilet paper. It seems like this becomes the crisis item whenever something bad happens in the world that people always glom onto. I don't really know why that is, but paleontologists do need toilet paper in order to do some of the most important things we do, to conserve the records that we find from fossils. Now, I'm going to be going through a couple of key steps that are involved in a successful paleontological expedition. The discovery process, the excavation process, and the conservation process. Basically, how we find the stuff, how we dig the stuff up, and how we make sure it doesn't break. It may surprise you to learn that fossils can be found, well, a lot of places on the planet. I mean, it's not the most abundant kind of rock in the world, but from the North Slope of Alaska to the mountains of Antarctica, from the Sahara Desert to the islands of Hawaii, from the Amazon jungle or the Congo to the deserts of Australia, and all over the state of Virginia, fossils can be found in an amazing variety of places. We're spoiled for choice in some ways. But to successfully pull off a paleontological dig, you not only have to know where you're going to be looking, you also have to know what kind of fossils you're going to be looking for. That includes the time period they come from, and also the kinds of fossils you're going to find. Now, the classic sort of Jurassic Park fossil locality where you're out in a dry, dusty wilderness and you're digging up the large bones of backboned animals, dinosaurs, mammoths, whales, even fishes, is one kind of fossil site, but it's not the only kind. There are other sites that are dominated by the remains of small backboned animals. This is particularly common in cave fossil deposits where you only find tiny little pieces of the small members of that environment, and not so much the giant things that you typically think of when you think fossil. And my friends and colleagues who are paleobotanists, those that study fossil plants, and invertebrate paleontologists, those who study animals without backbones, would be annoyed with me if I didn't mention that there are some fossil sites where you find huge abundances of leaves, of branches, of tree trunks and giant stumps from ancient forests, and not a bit of the skeletons of ancient backboned animals. And there are also sites that are dominated entirely by ancient reefs made up by invertebrate animals, those without backbones, and just huge concentrations of shells from ancient clams, oysters, snails, the relatives of ancient squids, all kinds of different sites. And then there's some incredible fossil sites where you basically find all the different pieces of an ancient environment buried together in one place. And each one of these kinds of fossil sites requires a different approach in terms of the paleontologist toolkit. To speak to what I know, I'm going to be talking about the tools we would need at one of those classic fossil localities where you find the bones of fossil vertebrate animals. Once you've selected a fossil site to dig in, then you need to plan what kind of tools you're going to be bringing along. In many ways, preparing for a paleontology field expedition is a lot like prepping for a hiking trip or a camping trip. You have to be prepared to spend a lot of time out of doors. So you got to have clothes with you that are particularly ones you don't mind getting dirty, like these white pants. Probably not the best thing for a paleontology field dig. You also need to be prepared to spend a lot of time under the sun. So it's good to have clothes that wick moisture, you can sweat in and not get too disgusting. Sunscreen, bug spray, hats, anything to protect you from the elements around you. And once you reach a fossil site, you're not necessarily going to find a vast open space that is covered in the bones of animals for you that are already ready to be excavated. That doesn't happen all that often, although it can happen sometimes. Usually, you only have a small sliver of the area that has bones coming out that is easily exposed. The rest is often covered in what we call overburden, rock that lays over top of the fossil layer that you want to dig that doesn't contain fossils. Fingers crossed. When you're dealing with overburden, that's when the heavy digging tools come out. The Paleontologist Toolkit includes shovels, pickaxes, rock hammers. In the case of some of the hardest rocks, you can even deal with a rock saw to dig through those. Once you have those tools, the back-breaking work of removing that overburden from the layer on top of the fossils begins. Once you get down to the fossil-containing layer, then things get a little more precise. And I have some of the tools that you'll need right here with me. Digging tools in a fossil-rich layer are often kind of precision ones. I really prefer something like an awl. This one has a somewhat bent end, and because this allows you to dig a relatively small area without necessarily damaging bones that might be right next to where you're digging. It's also important as a paleontologist to keep your workspace clean, so if you do happen to chunk off a piece of bone, you can easily find it and repair it. And that's why something like this is required. Paintbrush, whisk broom, all those kinds of things to keep a clean workspace so you can successfully find everything that you happen to be digging up. It's also really good to have a pair of gloves. Something with nice sort of hard palms and knuckles and stuff like that, because when you're digging through rock, you're bound to smash your hand against something. So it helps to have some protection. In some fossil sites, the bones you're going to be finding are tiny. So even something like an awl or a screwdriver might not be a precision enough tool to successfully excavate. In that case, same tools that your dentists use might be the most important things that you have. Seriously, dental pick. Nothing quite like it. Now, the first instinct when you find a fossil in the field is, ooh, what is it and how do I get it out? And you have to fight that instinct. It is hard. It's definitely what I experienced when I was first discovering fossils. I just wanted to know what I discovered so fast. But the best way to do it is not to excavate it in the field. There's always the chance you're going to break something, lose pieces, and you'll lose scientific information as a result. So when we find a fossil, the most important steps are to try and preserve it exactly as we discovered it in the field. One of the most important tools for that is maybe one of the most surprising in paleontology: glue. That's right, paleontologists, when they break fossils, use various types of glues to fit those pieces together and rebuild what was broken. Some of it is a lot like super glue. You basically are adhering two chunks of a fossil that broke and fitting those two pieces back together. In the field, we often use a very kind of watery glue. It's heavily dissolved, called a field consolidant. Those consolidants we pour over top of a fossil and the surrounding rock in order to just tightly adhere everything together. It seeps in between all the little cracks created during the fossilization process to preserve that specimen as close to what we discovered in the field as possible. When wrapping fossils for transport, it's important to have the right tool for the right job. This is the first place that toilet paper comes into play. When you have nice dry specimens out in the field, you can wrap them in this. It's nice and soft, allows them a little bit of cushioning space, and you're good to go. In areas with moister rock, it's best to have something like aluminum foil that doesn't really absorb the moisture around the specimen to keep it nice and secure. Now, in some cases, it's best to be even more secure than wrapping the specimen. This is especially true of larger specimens where you could never really wrap a whole dinosaur skull in aluminum foil. That would be a lot of aluminum foil. In that case, paleontologists build what we call a plaster jacket. Essentially, what you'll do is if you have a specimen that you want to build a plaster jacket around, you will build a pedestal, basically build a mushroom of rock around the original specimen. You'll carve it out. Once you've done that, you cover that whole pedestal in something like toilet paper, usually toilet paper itself, wetted ever so slightly to make it a nice moist surface. And then you mix up plaster of Paris. This is sort of a white powdery substance that when exposed to water becomes sort of milky in consistency, and eventually, once it dries, will harden into a really rock-hard, solid coating around whatever you happen to be working on. When paleontologists mix up plaster, we then use straps of the bag material burlap, cover those in plaster, and cover our entire pedestal of rock in order to get a nice secure coating of burlapped plaster all around it. If that dries properly after a few hours, or in some cases even a few days, you have your specimen and the surrounding rock embedded inside what is one of the most secure environments to get a fossil out of the field, into a vehicle, and back to whatever lab it happens to be going to. You flip the original plaster jacket over, cover over with more plaster whatever is exposed underneath, and then you're good to go. You've built a plaster jacket. And I've seen plaster jackets in museums that haven't really been opened, even though they were made over 100 years ago. It's just because there aren't enough paleontologists working on it, unfortunately. But those specimens, thanks to the plaster jackets, are, in large part, safe. So those are the main steps you need to keep in mind when you're getting ready to discover, to excavate, and to conserve fossil specimens. And there's one other thing that is a really important tool to keep in mind, and that is this: a notebook or a journal. A field notebook where you keep track of everything you can about whatever dig you happen to be on, whatever expedition you happen to be in charge of or involved in, can be a super important tool in the future. Paleontologists may want to know whether two of the specimens you found were discovered really close to each other. Field notes can tell you that. They may want to know how close in time two specimens were excavated. Field notes. They may want to know, where you had breakfast and happened to see a fossil sticking out of the rock in the parking lot. Field notes. All of those things are super important to keep in some kind of written form, some kind of journal, even one that's in rough shape, in order for future generations, even over 100 years in the future, can understand what you were doing when you were digging. The field expedition is really one of the most exciting parts of paleontology. You get to be involved in discovering new fossil specimens, and it's important to think about what that actually is like. When you uncover the rock surrounding a specimen, you are the first person that has seen that organism, whatever it may be, in a long, long time. Millions of years in many cases. And you will always be that discoverer. That will always be yours. And if you're involved in a big, well-done field expedition, your name will always be entered into the collections database alongside that specimen. Unfortunately, due to the current crisis, we've had to cancel some of our field work for the year at the VMNH. And that's the case with pretty much paleontologists all over the planet who've been canceling trips. I've heard of trips canceled from Wyoming to Madagascar. I'm really hopeful we'll be able to start making plans for more trips later in 2020 relatively soon. Because honestly, I look forward to telling you about that. telling you more tales of ancient life. Now, in coordination with Virginia Museum of Natural History educators, I've developed some basic activities for students who happen to be watching this video. For kindergartners through second graders, you should make a list of the tools that you think you would need to join a paleontology dig. You can talk about the ones I talked about here, or anything you might think could be really important. Be sure to be able to argue why every single one of them is important for your expedition. For third graders through fifth graders, and indeed anyone who really wants to do this, pick a place on the planet. Any place will do. And then, with a trusted parent or guardian, go on the internet and try and find the fossil sites that are close to that place. Then, plan an expedition to the site. Decide when you'll go, who you'll bring along with you, and the kinds of fossils that you plan on excavating, and the tools you'll use to do them. If you have a student that decides to do these kinds of activities, please comment on the Virginia Museum Facebook page with what you came up with, what you brought on your expedition, and where you wanted to go. I'm Adam Pritchard with the Virginia Museum of Natural History, bringing you tales of ancient life. Been finding some of my dinosaur toys from the past in my stuff in my house. These are always the most ridiculous to me. It's like a 90-degree mouth that's in a constant roar. Look at this thing. This is not what Stegosaurus looked like. But it's hilarious.